Hello everyone, this is Zheyuan Yang. Today I'm happy to share our submission to the text captioning challenge. This is a collaboration between Microsoft and the University of Rochester. Our submission is built on our CVPR paper, Text Word Pre-training, short for TAP. So we'll first introduce the core idea of TAP and then present the additional modifications over the TAP in this challenge. One major challenge of text VQA and text captioning is to jointly understand the information from different modalities, that is the text word, visual object, and syntax. For example, in order to generate a good caption or correctly answer the question, the model needs to jointly understand the referents and entities in different modalities, such as the ones shown on the left. Empirically, we observe that the answer or caption loss alone, as in previous studies, is inadequate to learn a good joint representation and thus potentially limits the main task's performance. In this study, our key idea is to introduce intermediate supervisions to help the joint representation learning and thus help text captioning and VQA. To this end, we propose text-aware pre-training, short for TAP. In the pre-training stage, we design various syntax-aware pre-training tasks to help the joint representation learning between text, word, visual object, and syntax. In the fine-tuning stage, we initialize the model with the pre-trained weights and train the model with the question answering or captioning loss. In this study, we focus on how to make the pre-training effective for syntax vision language tasks, which we refer to as the text-aware pre-training. Compared with general vision language tasks, one major difference is the existence of syntax modality. Correspondingly, we present the pre-training task design in two parts. That is the one between text word and the visual regions, as well as the one between syntax and the visual object regions. For text, word, and the visual region, an intuitive starting point is to borrow the pre-training task from the vision language pre-training studies, namely the mask language modeling and the image text matching tasks. However, we found directly adopting these two tasks show limited improvement. We conjecture that the major reason is that the original text contain limited syntax-related tokens. Therefore, the model tends to overlook the syntax word and regions during the pre-training, and thus show limited improvement on text captioning and VQA. To address this problem, we propose to include the detected syntax words as the additional text input. Other than visual text alignment, text captioning also poses challenges on understanding the spatial relationship between visual regions. For example, understanding the company name core slide has this visual relationship on with the object screen. To encourage the model to learn such spatial relationships, we propose a new pre-training task named relative position prediction, which predicts their spatial relationship between two randomly sampled visual regions as a classification problem. Another advantage of pre-training is that no answer or caption annotation is required during the pre-training stage. To better utilize this advantage and unleash the power of text-word pre-training, we clean and generate a large-scale syntax-related image captioning dataset from the conceptual captioning CC dataset. We end up with the OCR CC with more than 1 million images with syntax and use these images for pre-training. We have just presented the core idea of text-word pre-training or TAP. Based on TAP, we make a few modifications to further boost the model's performance in this challenge. First, we find it important to distinguish the syntax and fixed vocabulary words in generating caption supervision. We modify the method such that we do not encode a word as a fixed vocabulary word if it matches any detected syntax. Second, we find it helpful to use stronger visual features. Specifically, we experiment with the visual region feature from VNVL. Third, we found the OCR quality important for text captioning and VQA. We boost the OCR upper bound by feeding the syntax regions detected by two OCR engines, namely Orizota and Microsoft OCR. Finally, we further improve the model performance by increasing the number of transformer layers from 12 to 24 with a same hidden dimension of 768. This page lists the full results on both the testing and validation set for reference. Thank you. For any questions or comments, please come and chat with us. Thank you.